In this video, I will talk about the factors that affect chemical equilibrium, and the most important concept here is Le Chatelier's principle, and this principle states that if an external stress is applied to a system at equilibrium, the system adjusts in such a way that the stress is partially offset as it tries to re-establish the equilibrium. So we can change the concentration, we can change temperature, we can change pressure, we can add catalyst, and the other things to affect the equilibrium. However, I want to go one by one. So firstly, I will mention the change in concentration. So we can start with an example, and I will write a reaction. Iron 3 plus thiocyanate. We have iron thiocyanate, and what happens, for instance, if we add sodium thiocyanate? So obviously sodium thiocyanate is soluble in water, and if we add it, it creates sodium plus thiocyanate ions in water. And if we add sodium thiocyanate, then cyanate ion concentration increases, right? And if you look at the Le Chatelier's principle here, so we applied a change, right? We increased the thiocyanate ion concentration, we increased cyanide concentration. When it increases, then the equilibrium goes to the left side or the reactant side. So this side is reactant side, and this side is the product side. And we can continue. What if we add the oxalic acid? So this is the oxalic acid, and oxalic acid ionizes in water. This is carbon. So it ionizes in water. And this ion again ionizes and creates this ion. So the issue is that iron thiocyanate, so 2 plus, reacts with the ion and it creates iron complex. So we deplete the iron thiocyanate, and which means that concentration of this iron thiocyanate decreases, and there will be opposite effect due to the Le Chatelier's principle, and the equilibrium will go to the reactant side, or equilibrium shifts to right side. It is the same thing. What about the pressure? So we can change the pressure. So I will not consider the oxalic acid. Think that this reaction is at equilibrium. And we have a container that includes the iron thiocyanate, iron 3 plus, and thiocyanate ion. And we have a piston, right? And we can we try to increase the pressure. Does it cause a change if we increase the pressure? The answer is no. The pressure does not affect this reaction. The reason is that this is an aqueous solution and we cannot compress the liquids. We can compress liquids and solids. Therefore, there will be no effect if we increase the pressure. But something is not valid for this case. For instance, firstly, again, think a container. We have a N2O4 gas and ONA gas. So I am considering this reaction. And we have a piston, right? And we want to increase the pressure by changing the volume. So it is a gas phase reaction, and we definitely affect the gas pressure by compressing it. So firstly, we have to consider the equilibrium expression, K, and we can write it. Partial pressure of NO square over partial pressure of N2O4, right? So if we increase the pressure by pressing the piston down, we create a new QC. In this case, NO pressure, partial pressure increases more. I will write a small character. So what will be QC became bigger than the equilibrium. So NO partial pressure increases more since it has a square dependence, and the system set the new equilibrium by shifting it to the left. So if we increase the pressure, reaction will go to the product side. So I want to make another example. We have this reaction, so we have to be careful. This is a solid, this is gas, this is solid, and we have another gas solution. And what happens if we increase the PBS? So it's a solid. And as you remember from my previous video, equilibrium constant does not include the solids and the liquids. So the equilibrium expression, equilibrium expression of this reaction is pressure of SO2 gas over pressure of oxygen gas to the third power. So if we increase the PBS, as you see, there is no PBS in the equilibrium expression, so there is no effect. But if we increase the oxygen partial pressure, then the reaction go to the product side. The reaction shifts to the product side if we increase the oxygen pressure. And we can add catalyst, but as you see, this is so we have a reverse reaction and the forward reaction. This is forward reaction and this is the reverse reaction. And if we add the catalyst, then reverse and the forward reaction rates will increase, but it doesn't change the equilibrium, so there is no effect of adding catalyst. But the reaching equilibrium will be sooner if it is not in the equilibrium. So adding catalyst can help to facilitate the equilibrium sooner. But there is no effect on the equilibrium expression. And we can add inert gas, right? And if we do not change the pressure, so again, I want to think a container. We have the reactants and the products here. And we are adding the argon gas. But if we are not increasing the pressure, there is no expression for the argon gas here. So it's an inert gas and it doesn't react any other chemicals here. So again, there will be no effect of adding a catalyst. And temperature is the also another parameter that we can change. But before considering the catalyst, we have to know that whether the reaction is endothermic or the exothermic. And to understand it, we have to look at the change of n-type. So again, we have this kind of reaction, a similar reaction in a gas phase. And N2O4 plus heat causes the formation of NO2 gas. And the delta H of this reaction is plus 58 kJ per mole. So this is a endothermic reaction. And the reverse reaction to N2 gas becomes N2O4 and it causes the heat formation. And the delta H of this reaction is minus 58 kJ per mole. So this is exothermic reaction. And if we increase the temperature, it increases, so the endothermic direction will be favored. So if we increase the temperature, endothermic reaction will be favored more. And in this case, if we increase the temperature, endothermic reaction will be more favorable and 2N2 gas formation will be formed more. So the reaction goes to right if we increase the temperature. And opposite is true. If we decrease the temperature, then the exothermic reaction, this one, N2, N2O4 formation will be favored. And the reaction go to the exothermic direction. And N2O4 will be produced more if we drop the temperature. And if you have questions, please make a comment, and thank you.